Finally, we are coming to the another stage, that is software maintenance. Okay, in the evaluation. So what happens in the the word says that software maintenance. So any systems the softwares are going to be present, then maintenance of that is going to be taken care very cautiously, because once you going to develop the software, then heavy usage of the data, if you are going to use for that particular system, then it is not going to cope up with the environment. So you have to, it needs the updations or upgradation of the software. So that is nothing but maintenance of this software has to be done. So now when it should start, basically when it is going to be put into the use, that time the maintenance is going to start. Okay, some changes for the customer software that they are going to request, then again the changes are going to be get implemented and maintenance is going to get started with that environment. Some major changes are going to be not acceptable in the maintenance, and the implementation of this is nothing but modifying the existing components if it is going to be there. Okay, adding the new components also going to be considered. Maintenance has some types. First is fault repairs, environmental adaptation, functionality adaptation and modification. In case of fault repairs, so any bugs that it has been found, okay, or vulnerabilities are going to be found, those things are going to be get corrected, and it meets the according to the requirements, whether it is meets or not, that should be checked. Then next is environmental adaptation, where the operating system is going to be different operating systems environment, that your system is going to get adapted or not, that it has to be checked. And some point of view, the operations of the different environments like computers, operating systems, hardwares, softwares. Okay, so implementation is the initial implementation is going to be the first task that it has to get implemented properly. So whether it is accepted or not, that time that it has to be get checked. That is what the maintenance that you have to do it. Functionality adaptation and modification. It is nothing but any modification will be there for the application, then that particular data, whether it is modified data is going to be present, that it meets the requirements or not, that it has to be checked. That is nothing but maintenance of the functions. See, maintenance effort distribution chart, it is going to be is a pie chart. So out of 100%, where all the things are being distributed, fault repairs are 24%, functionality adaptation and modification is 58%, and environmental adaptation is going to be 19%. Means almost more than 50% the functionality adaptation and modification is required for the any applications. Okay, more time is going to be spent on this. So maintenance is going to be there for the any applications with this particular percentage. Fault repairs are going to be less because already it has been tested so many times. Okay, so there will be less repairs are going to be there. Environmental adaptation, this is also going to be less because by seeing all the efforts, all the environmental conditions that has been seen, and based on that only it has been adapted in that particular site. So changes are maintenance are going to come very less for this particular application. The cost result on that day only I said, in the beginning of this particular chapter only I said, whenever that we going for this particular chapter, that is maintenance, okay, costs are going to be more. Usually the development cost, okay, greater than the development cost it is going to be. It is saying that here 2 to 100% depending on the application. It starts from multiple times. The data is going to be, so development, more than the development cost, maintenance cost is going to occur. Okay, it is going to check with the functional and non-functional factors. The maintenance has been checked, verified, and increased by the any increases are going there, I mean incremental changes are going to be there. So the maintenance are to be considered for this particular application. Then agile methodologies, if they are going to use old common languages they are using, if they wanted to change for the new languages, and adaptation changes, that it should be accepted. And aging of the softwares, it is going to be there. So, okay, so you should support for the other languages. So other languages, the cost is going to be more for that. The prediction, maintenance prediction, when it may occur, that it is. Prediction maintenance cost. So every year the maintenance cost is going to get increases. Okay? We cannot say that this year if it is not comes, next year it will not come. We cannot say that, because the system is always in the evolution stage, and definitely that will be going to get the maintenance cost. Predicting the system changes 100%. Any time that it is going to have the request for the change, or the either modules or functionalities of those things are going to be adapted in that. Then we have the system, and most likely the affected by the change request. Problems are going to raise when the new request is going to be occurring, and that module is going to get adapted to the system. Then again testing and all these things that it has to be done. So when we will be going for all the phases of testing, then definitely the whole part of the system that it is getting affected. Next is your prediction of maintainability. Which are the parts that you want to maintain as a system concern with that? Okay. It is going to be costly, because most of the expenses are going to be goes in the maintenance. Okay. That's what the cost is going to increase over there. And some point in prediction of the cost is going to be lifetime maintenance is going to be there. Okay, the cost is going to be get lifetime, because that particular software only that you are going to use for the longer duration of the time. So that time maintenance is going to be predicted that in a year or 2 years that it has to be upgraded. Once the upgradation comes, all these costs is going to get increases. Maintenance is going to be done for that particular system. Otherwise, the product is going to be under the failure, we can say, because it is not going to be adaptable for the change. Hence, it is going to be no use of that particular software. Same thing that it has been discussed here. Change predictions. The complexity is going to be more for the matrix, because it is going to be dependence on the maintenance. Okay, how many complexities are going to be there, like in the program. Okay, control structures will be there, data structures will be there, objects will be there. Okay, different objects and methods. That's something about procedures that you will want to. Whenever you want to write the programs and all these things, you will never going to think that the program, the function is going to be small or big. You're writing the programs, and the complexity is going to be more in that, because the project is not so simple. It is going to have always the different control structures will be there, data structures are going to be there, and functionalities are going to be present. So when all these things are getting included, the complexity automatically it is going to be increases, and maintaining of these things is going to be very difficult. Process matrices, it is assessed by the maintainability, means how many number of times the request has come from the maintenance for the corrective actions, so that it should be checked. Average time required for the impact of the invoices, means number of times if it is going to come, within the how much time that you can able to correct that particular problem will be resolved, and time taken to implement that change. If new changes it is being given, how much time that it is going to be taken to adapt that one into the system. Time factors that are going to get calculated in that. Then alternate change request, how many number of times the request that has been made by